Welcome back to part two. Somebody brought up this picture. This picture is in no way representative of hackers. It just isn't. Hackers are people who look just like all of you. If they were walking down the street, you'd have no idea who they were. They don't wear hoodies, they don't sit in front of green screens. That's the media. And that's why I use this picture, so that we can have a conversation, because at the end we're going to have a much deeper conversation about what hacking really is and about our response to it. That's just somebody's artist conception because it looks dramatic, but it is in no way representative of what hackers are. So, part two. For those of you who missed part one, shame on you. These are the things we covered. You can go back and look at the video and you can get the context behind them. Now, the last one generates a lot of controversy, and let me just go ahead and tell you, this is not bug bounty hunting. This is gaming the system. Writing a minivan by putting vulnerabilities into your code is not bug bounty hunting. So, the art of war. Sun Tzu said that all battles are won or lost before they're ever fought. That's absolutely true. It's in the planning, it's in the intentions. One of the things that drives me nuts is every time I hear a CEO, and I heard a podcast the other day with the CEO of a company called TalkTalk, which got penetrated multiple times. It's in England, saying, you know, the bad guys only have to get lucky once. We have to get lucky every time. Which sounds really good, sounds really intellectual, but it is total garbage. It's not about luck. If you are depending on luck to protect your systems, you are going to be sadly disappointed when you find out you don't have any luck. In fact, any luck you have is just bad. If anybody's got good luck, it's them. What this is about, it's about intention. It's about our planning. It's about the way we go about constructing software in a way that makes it more resistant to people attacking it. So, let's start with static analysis tools. Let me say from the outset, I love core guidelines, CppCon, Clang Tidy. I use them all the time, probably every day. But I tried just as a test to go through and see which ones of the pieces of code that we saw in the first half would they catch. And with the exception of one, which is the variadic function, which is probably the least offensive that I have in there, I had to actually go turn that on. That's actually a specific rule in Clang Static Analyzer. So the reason why these don't work very well for security is they're not security focused. These are the kinds of things, it's for correctness of your code, which correctness for your code is the foundation of writing vulnerability-free code, but it's not the end of it. So if you're relying just on these to protect you, they're not going to work. So there is a series of static analyzers that are specific to security. So it's a lot like, in fact, I just had a conversation with a gentleman during the break where we were talking about the internals of this. These are much more sophisticated. They are going and looking for, again, patterns. But the problem is that, one, they can produce a lot of false positives, because these are, the bugs that we tend to write are not exactly easy for a static analysis tool to find. So what happens when we get a lot of false positives? We turn it off. There are tools out there. One is called Coverity. So these are commercial tools, Coverity, Sonar. PDS Studio is upstairs, so you might want to stop by and talk to them about what they offer. They do not catch everything. They won't catch, in fact, a lot of the issues that we went through in the first half, they won't catch. CERT also has a thread safety analysis piece that's part of Clang, which is very good. There's also some experimental, Rose checkers is kind of hard to use. You have to use their VM, and it only works with their compiler. Some of these other ones are really, really, really experimental. So part of the problem with static analyzers is they're only good as their rule set. So they're specific, and then they have heuristics built on top of that. It's kind of like virus scanners. Virus scanners look for patterns, and then they've got heuristics. But in this case, they're not going to catch everything. Because a lot of that behavior that makes our code insecure is beyond their ability to. So for example, environmental settings, third-party libraries, things that it really can't see into. So these work for, are you using string copy? That's a pretty easy one for a static analyzer to get. So now we have, and somebody brought up dynamic analysis tools. So there's some very good ones out there. What these do is these find vulnerabilities in running code. So what you're looking for is you're going to run these when your code is fairly well along. It's going to go out, it's going to find out whether you are overriding memory, it's going to find out whether or not you've hit undefined behavior, whether or not there's threading models built into it. So these are the kinds of things that you need to have running code for them to work on, and they're quite good. So the place, though, where they really shine, at least the places where I've seen them really shine, is in your performance, stress, and scalability. So you're going to get to a point where you've got a pretty good code base, you're now doing some deep testing, you are pressuring the system up to its limits to see how it behaves, to see whether you can break it, and that's where you're going to find things like threading issues. We can all get past, in fact, we'll deal with some of these later. You can get past threading issues just in your functionality testing or even your regression testing, but it's only when you pressure that system up that you find it. So fuzz testing, somebody else asked about fuzz testing. Fuzz testing is, remember we talked about interfaces, so I have an interface and I'm taking a certain amount of data into that interface, certain types. I want to then go and see what happens when I put nonsensical data into it. And then I want to go and put a different type of nonsensical data. So I'm constantly rotating that data, changing the data to see if I can trip over things like buffer overflows, things where you have just simply taken a value, slammed it right into an enumeration, and then you wind up having a failure. So the best ones that I've found are the OSS Fuzz, libfuzzer, and American Fuzzy Lot. Now, one of these found the Heartbleed vulnerability, and I think I watched Chandler do this one time on a video where he actually used fuzz testing to expose the Heartbleed vulnerability. So the Heartbleed vulnerability was just it was a memcopy overflow. It's an unrestrained memcopy inside the TLS heartbeat inside of OpenSSL. Most of these, though, if you want to use them, require you to be open source. So it's the best ones want to help the open source community. So I don't have price ranges on things like that, but they are very good. One of the problems with fuzz testing is it can be rather a challenge to deploy it. It's not simply a matter of, okay, here's my IPC interface, please go and do your work. What you have to do is do it almost at the class level. If you want to see somebody who did a very good presentation, go back to C++ Now early this year, and there is Marshall did a whole series on how fuzz testing works, and you'll see the complexities of it. It's almost like TDD, where you don't really just get to give it an interface and it figures it out. It has to, you have to program it to do this. One of the things that's nice about these is they use a lot of genetic algorithms and heuristics to be able to learn as they go on your interface. So it's very good for going back and doing this over and over again as you've got code that is getting more and more mature. So this is where the situational awareness from the last talk comes in. If one of the parts of the situational awareness is I'm not testing for bounds checking, I'm not testing to see if I fit within a range, and this is a good place to go and test for those kinds of situations in an automated fashion. So penetration testing, a lot of companies have penetration testers come in. What this really is this is where you're actively looking for vulnerabilities. If you go and you watch a penetration tester work, they know the patterns, and they'll just walk those patterns. They're going to look at security, they're going to look at, can I send stuff to you and you're going to process it when you really shouldn't? Have you got everything patched? So penetration testing is a way of looking at your system from the outside and seeing, can I get into that system? The problem with penetration testing is that it requires a significant level of security experience. You have to know what to look for. You need to know the patterns, because those are the first things you go after. And some of the tools we use are the Metasploit framework, which is a very good, it's an open source framework, which we go out and every time there's a new exploit, great, let's go plug it into the system so we can go test for that in our environment. And then Nmap is also very good, because one of the things that I want to do, if you set up a network, one of the first things they'll do is turn off ping from the outside. And the reason why is you don't want people mapping your network from outside your firewall. Nmap allows you to go in and look for attack surfaces, look for things that they can go after. So these are very good penetration testing tools. So a couple of other options if you don't want to get into penetration testing yourself. One is you can go to Black Hat and you can find a company to do it, which is a pretty good suggestion. DEF CON, maybe not quite so much. The other thing is let the hackers help, and I want to qualify this in that what I'm suggesting that you do is you set up your system so that it can be attacked. So when you watch people attack your system, when you have to go and do a response investigation to find out, so you do your incident response, you'll find out how they got in. So here's the thing is, don't put it inside your firewalls or on any network segment that you do. That would be bad, because if they get in there, then you're in your network. Don't use real data. That's happened before, where people went, and we call them honeypots. They set up a honeypot, except the problem was they used actual data, and then somebody breached it. Imagine that. And then they had the data. So what you're looking for here is, I want to go take my system, put it in a vulnerable state outside of my firewalls. I want to let people hack it, and you will be stunned at how quickly people will attack your system. It is breathtaking, the speed that people will go after it. And the really creative ways they'll figure out ways in, and where they're coming from. We all tend to think that it's somehow foreign nationals that are wanting to come after systems. It's not. I mean, you're going to find lots of US IP addresses that are coming from American hackers. So this works. Penetration is for something you do sort of late in the cycle when you have a full system. So the best practice here, all testing is asymmetrical. There is no silver bullet. There's not one single thing that if you do this thing, I can say, okay, we're good, we've taken care of it. It takes all of these things, and some of the things that we're going to be talking about here in just a minute. So has anybody ever done threat hunting, or we call it threat modeling too? Anybody? So a couple of people. Okay. So the answer is you all do it. Every one of us. We do threat modeling every time, or threat hunting every time we drive down the road. There's a car approaching an intersection. You're looking at that car. Is that a threat? Is that person going to come through the intersection and crash into me? If you've ever gone to a city you've never been in, a large metro like New York, it's after dark, you're walking around downtown, then somebody's coming towards you, you are threat modeling that person. Is that a good guy or a bad guy? So we do this instinctively, we just don't think about it. And things like darkness, isolation, insecurity, vulnerability. Anytime you're operating in a situation where it's unknown and you have these kinds of things going on, you are threat modeling. So the reason why we do threat hunting is because it's no longer enough to just let the automated tools take care of it. And we'll go through a little bit of an exercise here, and I'll show you why it's no longer available, but we need to understand the nature of those particular threats. So in order to understand this, I want to talk about intrusion kill chains for a minute. So these come from the military. The military has basically a way they go about prosecuting a war. You find, fix, and follow your enemy. So I'm going to find them, I'm going to keep an eye on them, I'm going to follow them where they go, try and keep them in a defined position. Then I'm going to come up with how am I going to attack my enemy, and then I'm going to actually do the attack, go back, assess it, and lather, rinse, repeat. That if you were to take the prosecution of a military campaign, that's basically what those steps come down to. And the same thing happens with hackers. So you have a threat actor. The first thing they're going to do is they're going to do reconnaissance. Now that could be reconnaissance where I'm probing your external interfaces, I'm looking at your firewalls, I'm trying to see what the reflexes are. But I will tell you right now, that's actually really old school. Because the problem is you will get alerted to that. There is actually a better way to do this, and that is doing reconnaissance on all of you. So let's say I want to go and I penetrate, and these group of people here are people who work for the same company, and I want to penetrate that company. One of the easiest ways for me to do it is to get somebody to click on a link, but in order for get them to click on a link, I need to send them a link in a way that they'll click on it. So I go out and I go to LinkedIn, and I find that you all work for the same company. So there's a couple things I'm looking for. What are the relationships? I don't want 1 degree of separation. I don't want to send an email from the person you're sitting next to, because I know the person I sit next to and I know how they sign off their emails. But the person down in another group, which is a couple of degrees of separation away, I don't really know them. I may know of them, but I don't know how they sign off their emails. So when I want to sign that email from them, I don't want you to know that it's not them. So if your name is David and you always sign your name David whatever when it's somebody you don't know, that makes sense. But when it's your friends, it may be Dave. So if one of your colleagues that you work really closely with winds up getting an email from David whatever, I'm going, why is he giving me his full name? So this is the thing where when you do reconnaissance, you have to understand the people, and we'll see a case study where this happened. So I want to know who you work with. Who you work with that's sort of a couple of degrees of separation. I want to know your email addresses. A lot of companies have email addresses that follow some standard. First initial, first name, last name. So if I know 3 of those email addresses, I can figure the rest out. And then if I want to test that, I just send an email to their server, and if it's wrong, it'll bounce back an error. So now I can reconnaissance the people. But the other thing I want to look for is I want to look for keywords. If you're using a Windows ADC and you're using Exchange and you're using Outlook, I'd like to know that because there's entire classes of vulnerabilities I don't want to use against you. I know exactly the ones. And so when you do, for example, in the profile that you put onto LinkedIn, he'll give me some keywords, he'll give me some keywords, she'll give me some keywords, and I put them all together. So if I know you're using Apache struts, and I see somebody mentioning Linux, it's probably that your web server is a Linux web server. Why? Because 90% of all the Apache installs are on Linux web servers. So now I can focus on the kinds of exploits that I'm going to use it, and that's the second step, weaponization. What's the zero-day vulnerability that I can use against your system by just knowing something about it? So when you go look at your LinkedIn profiles and you look at the LinkedIn profiles of your colleagues, how much data are you giving me as an outsider wanting to attack you, so that it not only helps me do a better job of reconnaissance, but it also allows me to pick the right weaponization. Delivery. Delivery can be anything from, I send you a USB stick. Hey, here's this great USB stick. We're sending out free trials. Vladimir Putin did that one time. So they had a G20 summit, and he sent swag bags with all, you think we're the only ones who get swag bags. He sent swag bags with all the other leaders, except there was a USB stick in there, and the USB stick was loaded with malware. It was wonderful. It was really brazen, I thought. I mean, it was awesome. But that's what happens. They've run study after study. They go on a college campus, they drop a bunch of USB sticks, somebody picks them up. What is the first thing they do? They go plug it into the PC. Well, I was just trying to figure out who it belonged to. Okay, it doesn't matter. You just infected your computer. So that can be web. It can be, I give you some great deal. I give you an email. Anything that allows me to get you to click on a link you shouldn't. Or put something into your system you shouldn't. So exploitation, that's when the actual vulnerability goes into your system. Installation is where, now that I'm on that box, I want to move laterally within the system, so I'm going to begin installing a bunch of other software that you don't know about and that you don't want in your system. Then command and control, that's the point at which I now have full control of your system. So I've got some sort of conduit back to my my command and control server. Now I'm in full control of your systems, and if you get to step 7, which is action and objectives, you're owned. They're in the system, you're done. They're going to be running the things against your system that they want to, and there's very little you probably will not even know that they're there. So, Project Aurora. That was in December and January of 2009 and 2010. So they picked that time because there's minimal staffs to defend the networks. They ran exactly the exploit I outlined. They went, they looked at the staff, they crafted an email that even if you're an InfoSec would have looked perfectly legitimate. They sent that email out, somebody clicks on the link, the first thing that happened is it had a zero-day exploit for Internet Explorer, got outside the sandbox, installed itself into their environment. Then it opened up an SSL connection back to a command and control server, downloaded another dozen pieces of malware, installed that, and then began moving laterally within their systems. And what they were going for specifically, Google was a little more than just source code, but they were primarily interested in source code, which was if I can get Google source code, if I can get the source code for Adobe Flash, Adobe Reader, any of these products, now I've got the source code and I can go find zero-day exploits in the source code which is what I prefer. And that's exactly what happened. We found a lot of zero-day exploits cropping up right after that. What's interesting, and this is why we think it's a nation state, and attribution is where we go and we attribute it to a company, or a country, or even a company. Is they burned a lot of zero-day exploits doing this. This was a massive attack. It's the kind of attack you typically see in the military, which is why this was so stunning, is these were all civilian companies that were getting hit along with defense contractors, and we had not seen that. So, threat modeling is a response to kill chains. The first thing we have to talk about is the scope. If you make the scope too wide, you're going to get buried in information. If you make it too narrow, you're going to miss things. So one of the things I suggest to people is you do it as an iterative process. You start small and work your way out, or go deeper into your systems. Because what you want to do is you want to catch the easy stuff first, and then you want to begin moving out and catch the harder stuff that hackers will probably find for you. Model creation. What we care about is where data moves and where it pools. You'd be surprised the number of times when people go through threat modeling sessions and they find out, it's like, I didn't realize we were keeping that data. You want to know where the data starts, where it's consumed. It should not just appear out of the ether. You want to know where all that data goes, and you're going to focus on the data flow. Then threat identification is, we're going to talk about trust boundaries here in a minute, but what you want to do is you want to know where are the threats. And there's several good models. We'll talk about Stride here in just a minute and go through a short exercise with that. But what you want to know is, you want to know where we're holding data you don't need, who's got access to it. So this is information in your threat modeling that you want to go and think about, and that's probably the strength of threat modeling, is when I have to threat model my system, you'd be surprised the number of people where you've got very large groups of developers. This group worked on this area, that group worked on that area. Now that they're all coming together, you're having these moments, oh, I didn't realize the system worked that way, because that's not a part of the system that they aren't used to seeing. Threat classification, how easy is to exploit, how much damage can I do, what can I get to from this? And the mitigation planning, is it already mitigated in some other way? Is there an inexpensive way to do this? So you're asking, basically you're prioritizing at that point. Does this go into our backlog if you're in Agile, or does it go into, for the next PI, or is this something that becomes our technical debt if it's low enough? And then finally, validation. You want to go through and follow up and make sure that you actually fix the problem, and that's usually with some sort of testing. So Stride is just an acronym. These are not all the things, but it's probably the best place to start. So spoofing, which is, can I masquerade as another person? Can I get you to give me data because you think I'm one person when I'm not? Tampering is just sabotage, pretty straightforward. Repudiation is, can I act without evidence of action? That's where your logging comes in. Can I go and do something on your system that you will then not know is going to happen? And the exploit that we're going to run here in a little bit, that's exactly the problem, is that you can run that exploit and you're not going to see it. Information disclosure is just the exfiltration of the data. Can I get to your data and get it off the box? Denial of service, can I render it inoperable? And then elevation of privilege is just gaining elevated access. So trust boundaries. Trust boundaries are how we define risk. Remember at the very beginning I said, okay, I have a trust boundary, it's my perimeter security. Everything outside is untrusted, everything inside is trusted. And that's how we assign risk. We want to know whether or not I'm going from one trust level to another. And we have the concept I mentioned earlier of zero trust environments. And we'll see how that affects the way we think about this. So trust boundaries occur when I cross a level of trust. I go from the outside to the inside. I go from operating as a non-privileged account to now operating as a privileged account. That's a trust boundary. So here we have just sort of a remote security system. Let's say it's a remote DVR. This could be on anything. It could be on a drone, could be in a car, could be in a factory, could be in a secure environment. In the center here we have sort of the working parts. You've got the AV processes, then you've got some data and configuration, and you can upload it that information to something down here on the bottom, which would be like an on-premises server. Or you can come over here to the right and you're uploading it into the cloud, and then you can access what's on the cloud through a web server. You would probably also want some sort of command and control for the on-premises, so you'll need some way to view data, some way to interact with it. And then you would want some command and control here on the device itself. How do I configure it? How do I go and look at data maybe in real time? So we have a reasonably complex system. And this is a good place to start without getting too deeply into it. So now the question is, where are the trust boundaries in this system?
The web server?
Yeah, web servers. Where else? So minimally, our trust boundaries are anywhere we cross a physical boundary. So our mobile down here could be a cell phone. In one case, it also could be a UHF VHF transceiver in another case. So I've got a drone flying, I want to be able to configure that from a distance. You have web browsers that can run command and control against the, to actually turn it off, turn it on, those kinds of things. You have a web browser that can connect into what you have in the, what you have on the, up here in the cloud. You've got data moving to another server somewhere on premises. So this could be something as simple as the drone lands and uploads all of its data. Any others? Yeah, great. So around those data stores, do I implicitly trust the AV processes? No, because these, we're talking about zero trust at this point. We don't implicitly trust the AV process. We may be doing encryption at rest, and that's enough to trust the process, because if the process cannot authenticate in order to do the encryption at rest, that's where I've tested to make sure I have verified the data and I validated who is sending it to me. The same thing with the data being flowed out. If we're talking about exfiltration, the data being flowed out of that server. So we need to make sure that the data is talking to the right server. So as you go through examples like this and you say, okay, where are the trust boundaries? What you have to ask is, where am I moving data? And then there's one at the top. That's the command and control. So if I'm somebody who wants to penetrate a system, one of the things I might want to do is just turn the system off and keep turning it off so that it doesn't operate. Maybe I'm trying to sneak into a plant, so I can now go turn that system off. Now there's no record. Your repudiation is now done. There is a way for me to get in, and you have no way of proving that I was in. So let's look at information disclosure. We're just going to do one of these for today. Normally what you do is you go through all of these. You'd also come up with what creative ways you can go and you can look at ways to penetrate this system, get data out of those things. So information disclosure, where am I worried about information disclosure? It's an easy one, just call it out. Well, where's the information? The data stores. So I need to make sure that when data is being accessed from those data stores, that I'm authenticating the person trying to get that information. So in this case, you've got data stores that are being accessed by a web server here, it's being accessed by a download program there, and this is being accessed by. But what about the static content? And static content is data too, and static content is used to interact with the data stores at almost every level through the browser and then through the website.
Also, are you partitioning your data stores in static content, or are they just big blobs?
Well, it's more, so the question is, are you partitioning your data stores or are they just big blobs? The question more is, am I securing them? Am I making it so that somebody cannot come in and replace my static content with somebody else's static, with their static content basically, which would give them access to my system? And then there's the web servers themselves. These are the things, in three instances, they have direct connections to the data. So what have I done? We mentioned, okay, I know you're using Apache Struts, and you've got a Linux environment. So now I have an entire set of vulnerabilities that I may possibly be able to use against it, and I would use it against these if I know they're Windows versus Linux. So those become the keys. So when you're going through information disclosure, you have to think about every link in the chain that talks to that data. That is the data itself and how it's accessed, the web servers, which are accessing that data. In most cases, in 3 cases, it's the web servers, and then the static content itself. Because if I can get in and put in different static content, now all of a sudden I get a different reflex out of that web server. So the takeaways. Zero trust environments are becoming the norm. Because if they can get into your environment, you have no trust levels anymore. Whether it's trust levels that are going across somebody being able to get into your system versus somebody being able to run a privilege escalation attack, we now have no, we now are sort of resigned to the fact that we don't have any trust environments left. Exfiltration is now becoming as important as infiltration. So it used to be that our entire emphasis was keeping them out, and we figured out, yeah, we lost. All it takes is, and goes back to the story I started the first talk with, one human being went someplace they weren't supposed to, and someone was able to get into the environment. So we're now focusing on, okay, let's assume they're in the environment. How do we keep them from getting our data out of the environment and into their hands? Again, it goes back to complexity. I talk about this all the time. In the same way that metal under fatigue, all the energy will translate to the part of greatest weakness, complexity is the weakness. You will find, you may get rid of all the vulnerabilities around it, but when you get to complex pieces of the product and you begin to discover emergent behavior, that is the time at which you say, okay, we've got something that's too complex, we need to simplify it. And it's easy with C++ to get into a bath of complexity. There's just so many ways you can do it, and then you don't realize that you've done it until it's too late. Threat modeling, again, it exposes the emergent behavior, but it also allows everybody to know the system from end to end. In many environments that I work in, I just worked on this piece. But there was a whole nother piece of the product that I had no visibility into. When you do threat modeling, include your entire team. Get everybody involved, because what you want is, you want everybody thinking about it, and especially you want new eyes. So here's where we use what? Not all these get used immediately. So threat modeling gets started really about the time when you start hardening your architecture, and you've got a pretty good handle that, okay, we know what we have, and I broke this actually up into, I made the comment the other day that the threat modeling really doesn't sort of fit into an agile paradigm, because agile paradigms will favor working systems over documentation. Well, the problem is that threat modeling is an inherently documentation-intensive process, so people tend not to want to put it in there, but you can break it up in certain ways. So you get to the beginning of your PI, your first few iterations are going to be architecture. That's the time when you want to begin thinking about doing threat modeling, because now you're looking at, okay, how well is our architecture going to be able to stand up? It also gives you the ability to go back and refresh your architecture. You may have made changes at the end of your last iteration that affected the architecture. You need to true up the documents and make sure that they're actually accurate and valid for the product that you're releasing. So static analysis starts really from the first line of code. Dynamic analysis starts when you have code that is pretty well along. The problem with running dynamic analysis when you have a wildly changing code base and you're making lots of changes to it is you invalidate what you ran before. Now you don't know anything. That prior data doesn't really tell you anything. And then starting with your fuzz testing begins when you have enough interfaces that you feel are fairly stable, and you're going to begin actually testing the code behind it. Fuzz testing, it's best, in the same way as TDD, it's best to start fuzz testing at a time when you're developing the interfaces, because you're doing them along at the same time, and that way you don't have to take this massive amount of interfaces that you have or classes that you've got, and now you're going to go and you're going to test it, and you've got to write all of this other infrastructure to be able to do fuzz testing. It makes more sense to do them together. And then penetration testing. That starts when you complete a story or you complete a feature, you've gotten something where you can actually go start doing some penetration testing on. Again, if you're changing it a lot, you invalidate the testing. So you want to get to the point where you feel like you've got a pretty good handle on a product and the product is pretty solid. So a couple of things. One of the things we always talk about is we want to build in layers. So we have the principle of least permissions. And this actually is a pretty good source of lots of bugs. I'm running in a minimal position or permissions. I need to go and escalate my permissions because I need to do something I'm normally not allowed to do. But in that code, I have an error or I throw an exception. And because I'm bailing out of that, I'm not resetting those permissions. So now I'm running at a much higher level of permissions than I should, which allows people to exploit the fact that you're running in an escalated level of permissions. And again, back to complexity. Bob was talking about this in one of his talks. It affects understandability. It is really hard to reason about complex code. So the simpler you can write your code, the more likely you're going to put code out on the street that does not have these kinds of vulnerabilities in it because they're obvious at that point. Another place is logging. When I want to penetrate a system, the first thing I'm going to do is I'm going to go grab all the logs I can get. Because you would be surprised how much we put in the logs. We're like chatty Cathy dolls sometimes when we do our logging, especially in the embedded world, because the first thing that we do in the embedded world is, well, we're going to go get where are all the registers, where's all the memory, and I'm like, great, I mean, that's wonderful. I need all of that, so now I know where to go after your system. So one of the things that, and we did this in the first talk, where we went and looked at the memory. Just because you're segfaulting does not mean that you should just bail out and say, oh, well, the memory's corrupted. If the memory's corrupted in a specific way, that tells you something. So capture that. And I don't know about anybody else who digs through core files, but that is not my favorite thing to do. Core files are really hard to get through. Log security. We don't really secure our logs, although we really should secure our logs. We don't encrypt them because we can't. There's no way you can encrypt your logs. You're going to wind up paying a huge performance penalty for the fact that you're encrypting the logs. But what you have to do is be careful about what you put into it. Don't put usernames. It may be convenient, but it tells me something about the system. It tells me about what permissions I might need. And our logs wind up being a treasure trove of information for people who are looking to go after a system. Audit trails. When you're logging, okay, so when we write a piece of code, what is the first thing we do? Well, we're writing out tons and tons and tons of information. Maybe we have 6 or 7 levels. But we don't ever really think about, okay, what if somebody has penetrated this system? What are the markers? What are the things I need to write to the log that tell me that somebody has done something in the system that they shouldn't? Our logs tend to focus solely on bugs, solely on this process ran, that process ran, this function ran, followed by that function. Instead, we can use them as audit trails. So if you treat logging as a way of knowing who's doing what and when, and you can obfuscate the user that's doing it so that you can go back and do it, but it makes it harder for somebody else to. Use your logging as audit trails, or have a separate log if you have to. So if you're dealing with, for example, you're dealing with evidence. There's the logs that I capture that tell me how my system is running, and then there's the logs that I put out that are the audit trail for that evidence, to prove that that evidence was not manipulated along the way. So audit trails are a really good way of dealing with repudiation. So the next best practice is secure code. Secure systems begin with secure designs. If you aren't designing a secure system you can make all the right choices as far as your software is concerned and the code you're using, but if you're not starting with a secure design, you've defeated all of that. So it takes both. We talked a little bit about code reviews here before. I don't know about you, but most of the code reviews I've been, it's, correctness, your line lengths are too long, I don't like your variable names, this is hard to understand, but we rarely go and look at it as, oh, you've got a security vulnerability, mainly because we don't think that way. But one of the things we do, because we don't want to irritate and alienate our colleagues, is we're not willing to be ruthless. I mean, it is what it is. You're either going to find the bug in a code review or they're going to find it for you. So if you're looking at people who are, a hacker will find it for you. If you're looking at code that is overly complex, if you're looking for code that you don't really understand it, don't just do a +1 on the review and send it on. Go back and ask for clarification. Go back and make sure that that's actually the code you want to do. And the other thing I got into is don't do +1s if you're using Garrett. Don't do +1s on incrementals, and we'll talk about that here in just a minute, why that's a bad thing. Because I've had cases where somebody actually introduced a bug or a vulnerability, but I +1'd it because I was just looking at the change they made here. I wasn't looking at the totality of the changes. And then legacy code. Legacy code, no, I mean, we'll be honest, does anybody here love digging through legacy code? Yeah, me neither. I'm not going to go so far as to say I'd rather have a root canal, but I'm pretty close to not wanting that. The problem is that they often have our worst vulnerabilities. They're the code that has gone back into antiquity. Nobody's looked at the code. Nobody's looked at it for a security review. It is simply a matter that that now becomes your vulnerability that you don't know is there. So ruthlessness really is a virtue when it comes to doing a code review. We talked a little bit about open source libraries in the first half. I prefer libraries that have a continual security check, because if somebody adds a breaking change or something that adds a vulnerability, it doesn't matter that it was code reviewed by a security company 6 months before. They just put it in today. It's in my code. So you have to be very careful about the code that you're using. One of the mitigation ways you can mitigate that is security wrappers. So if you have something's misbehaving and it's going to throw an exception, catch the exception and deal with it. Don't let it just bubble up to the top of the call stack. If you have a library that you suspect isn't really, maybe you fuzz test the library and find out, oh yeah, it doesn't handle all these things. You're going to have to build a wrapper around that library that handles the data sanitization for it. Because it really is true, you're only as strong as your weakest third-party library. Their vulnerabilities become yours. That's just the way of it. So let's talk about, does anybody have any questions before I go in there? Because I think I didn't, wait, I've got a bit, so let's do a couple questions. Go ahead.
What kind of vulnerability you have found in legacy code? What kind of vulnerability you have most often seen in legacy code?
The number one, period, is you didn't validate and you didn't verify. And I find that all the time in legacy code. I'm just taking the data that you give me and I'm operating against it. So the question was, what is the most common vulnerability I find in legacy code? And that's it. Go ahead. Okay, so the question is, what do I mean by incremental commit? So in Garrett, you can do a commit and you look at it and then you come back and there's some comments by it and someone comes and does a fix for it and they check in a patch. Well, in Garrett, you can go and you can look at just the patch. Did they really fix the problem that I said they had? The problem is if I don't look at it in the context of the whole commit, I've now just +1 something just because they answered my complaint about their code, but maybe they broke something else and I didn't look. So that's it. That's what I mean. Yeah.
How to do the input validation when the library isn't parsing? Like, for example, you read the image file, PNG file, you need to use this PNG. You cannot fix any file because then you have to write your own PNG parser. It's not in the library.
Okay, so the question has to do with a library that might be reading a PNG file, and how do you sanitize that? Feed it a garbage PNG file and see what happens. If it's going to choke on it, you're going to have to verify that that's a legitimate PNG file before you send it on to the library, if you don't have the source code. If you have the source code, you can go fix it. That get your question? Okay. Oh, you didn't get my answer?
Yeah. Would I need to write my own parser for PNG? Verify it.
So the question is, do you have to write your own parser? If you're using a library that you think is suspect and is going to choke on a PNG file, the easiest thing in the world for me to do as a hacker is just feed you garbage and watch your system go down. So yes, you may very well be at that point, or find a better library that's actually been tested for security and actually does its job correctly. And that's not always, and I know that's not a very satisfying answer, because sometimes that's the only library you've got. It's something very specific, you can't really do it. Then you have to go back to the code authors, you have to make a tough decision about whether or not I want to use it, or then yes, you have to do a front end that is going to protect yourself from that library.
I want to disagree about being ruthless being a good thing for code reviews ever, or necessary.
Okay, so Chandler says he disagrees about being ruthless, which I understand about in code reviews, which I completely understand because you have to work with these people. I'm not talking about ruthlessness as then I found a bug and I'm going to make you look like a total idiot. That is not ruthlessness. That's being a jerk. Ruthlessness is I'm going to look at this from the standpoint of somebody who wants to do you harm. That's ruthlessness. So I'm glad he brought that up because it's not the meaning. I'm not talking about making your colleagues look bad because then they'll turn around and make you look bad and you are going to wreck your team. This is about the people who will come after your code do not care about you or your feelings. So you have to look at the code as I don't care about my feelings either. Because you need to find the things out there. I got about 10 minutes left. I'm gonna catch your because I want to get through this, this particular exploit. You want to make sure that you are not just leaving it at, I don't like your line lengths, I don't understand your variable naming, the kinds of things we tend to see a lot in code reviews. Dirty cow. Anybody ever heard of it? Okay, a few people. So Dirty cow was a vulnerability in the Linux memory management system. Every system out there, so it was introduced in 2007, they didn't find it again until 2016 and get rid of it. It was one of those things where they fixed it one time, it was broken by another fix. Again, this goes back to the whole thing of looking holistically as you're checking in code, does it break other things? So it was fixed, it was broken, and then it was fixed again, but it stayed out there for 9 years until somebody caught it. We do know that it was actively exploited by pretty much all the evidence that's out there. So this is a vulnerability in the copy on write, which is where the name comes from, but every operating system has a copy on write system in it. In this case, by exploiting this, you can write to protected files, and it is actually fairly simple to do it. So this is the copy on write system for Linux. I have my file over here in the middle. When I read from it, I don't read the whole file into memory. I just read the segment the chunk that I want to read. So the program is going to read it. When I write it, because this is a read-only file, that I can't write to this protected system file, it's going to do a copy on write, and that's the vulnerability. So we use a function called menmap, which makes it read-only, so we open it and read-only. We can't read it and open it and rewrite simply because we don't have permissions to do that. We give this private setting, which is what enables the copy on write. And then you have a file descriptor. So here is, on the far left is a piece of code. We're going to open it for those of you who are not Linux developers. Process self-mem, that's just your memory file. That's accessing your memory for your process. We have a seek, because we're going to go to a specific place, and then we have a write, so we're going to write this out. But there's also another function called madvise, and madvise takes the file and basically tells the operating system, I don't need you. You can dump my changes. So if you look over here on the right, I will write to the file, which sets the dirty bit. Then I can come in and hit and issue the madvise, in which case the operating system throws it away. And then when I go to write to it again, the system first has to reread it. Why? Because I threw it away. So it has to go reread the file back in, or at least that section of file. What does that sound like the vulnerability is going to wind up being? Exactly, it's a race condition, it's threading. So I have two threads, I do a write, I do a madvise, I do a write, I do a madvise, I do it very slowly, everybody's happy with each other, we do it. But then what happens when I just start slamming a madvise in there? And I'm just doing it over and over and over again. In the case of this vulnerability, I can trick the system into writing to the actual file, the one that I'm not supposed to. Remember, the system is running as root. So it can write to it, it's just I'm not supposed to. So a couple of the files, targets we'd like to go after, etc password. So strangely enough, the etc password file doesn't have any passwords. It's just a list of the people who are on the system. So I created a little account called madcow, and the 1001 is just the user ID, the 1002 is the group. So if I could go in, because I can't write that, if I could go in and just replace that 1001 with all zeros and make myself root, suddenly I can log in as root. The other thing we can do is, if you notice these, we talked about this a little bit earlier, these, this ping 6, and SU, these are all where the set UID flag is set, which means that when I run these, I'm running as root. So if I can go in and just simply rewrite ping to handle the same interface, but it does something different the next time somebody runs it, all of a sudden they're doing something that they shouldn't in the system in the context of root. So here's our code. It's actually fairly simple. We're going to basically just open the password file. We're going to map to it so that we can map to a particular section. We're going to find a position, which I want to replace that 1001. So I'm going to figure out where that begins. Then I'm going to spin up 2 threads. One is the madvise and the read. The code for madvise and read is on the right-hand side, so we have, it just opens and then it just sits there and it runs forever. It just goes and seeks and writes, goes and seeks and writes. And then the madvise just keeps hammering that, telling the system, nope, throw it away, nope, throw it away. And that's where the vulnerability winds up being. So let's go look at how this works. So on the right-hand, yeah, it's your right-hand side. If you look down here at the bottom, you'll see my mad cow account. It's got 1001, 1001, 1002. So that means I'm just a regular user. And we'll run this out of the pane on the left. So I can log in as Dirty Cow. Do what? Oh, that's right, it's Mad Cow, not Dirty Cow. And I'm just a regular user, so I should not be able to get to the shadow file because I'm just a regular user. Access is denied, as it should be. So if I run, and this is just going to sit there and run and run and run and run. Now all of a sudden, that 1001 has been replaced by all zeros. So we're done here. And now I'm root. So this is from an operating system, it's a horrifying bug. And now I can access the shadow file. So this is one of those bugs you're not going to find it'll be hard to find it in the code review, but you're not going to find it with static analyzers. So as far as countermeasures, it's pretty much all just bad news. This code had been reviewed and reviewed and reviewed from changes. It still made it in. There's no logging, so repudiation is still intact. I didn't do that because you have no logging that proves that I did. And then other than a code change, there's nothing in the operating system. This is the operating system, so there's nothing there watching it to protect us. It's not like we can rely on ASLR to give us some protection. You might find this in a dynamic analysis. The problem is you have to know what to look for. The way I think this probably was discovered by somebody outside is I've got the code, I'm gonna go look and say, wait a minute, this doesn't look exactly right. I wonder if I can exploit that. And then I come up with a way of doing it, test it, and suddenly I've got it. So this is where having the source code becomes very, very important. So the last best practice, be committed. Like I said in the first talk, it drives me nuts when I hear CEOs talk about how, well, we have to get lucky every time. The hackers only have to get lucky once. If you are trusting that luck is going to fix it for you, it is not, because the luck will run against you. It's always going to run against you. There's hundreds of companies out there where the luck ran against them. But here's the thing. I own the software. That's why I picked the title. Your first line is the last line of defense. I own the software. I own the network. I own the infrastructure. I own everything that goes. The only thing that the hackers have that I don't have is they get to choose the time of the engagement. That's it. I have everything else, and that's why I did this picture. It's a completely ridiculous caricature. These people are not demigods. They're not geniuses. We can go do a whole talk based on all the times when they've messed up and put things out in the wild that made it easy for us to stop what they were doing. But the bottom line is that when it comes to my software, when it comes to my systems, I'm going to choose to either be the predator or the prey. And I choose to be the predator because they're in my backyard and I have no intention of just letting them walk in and waltz all over the things that I've created, and we let them get away with it. And that's one thing I want us as a community to begin doing, is stop thinking of this in terms of a problem we can't solve. It's solvable. It just takes training, it takes a different mindset. So it may not be a fair exchange, but you're either going to be the predator or the prey. You're either the hunter or the hunted. It's that simple in this environment. But the good news is you have all the controls. And so this is where it starts. So if you're interested in security, we have a lot of security talks. We have more security talks here than we've ever had. So we have a panel coming up Thursday. So if I don't get to all your questions, I'll be happy to answer them after, or come to the security panel. Besides myself, we have Patricia Oz, which I found out this week that you pronounce her name that way because it rhymes with awesome. Matt Miller from Microsoft actually does this for Windows. He actually goes in and runs penetrations against Windows to see if he can break the system and get into places he shouldn't. And then we have Michael Wong from CodePlay, who's been a part of the standards committee. He's part of several standards committees for a long time, which gives him an insider's view. And so Ava Conti, who's sitting in the back, will be our moderator. But there's other talks. So you've had 2 from me today. Patricia will be doing 2 this week, so she has Tuesday and Wednesday. You have Chandler Carruth over here, who is going to do what I think is going to be an outstanding talk on Friday on Spectre and Meltdown. And then there will be a panel after that. So you have plenty of opportunities here to engage people who are in this industry, who work in this, to find out, okay, what are the things we can do in order to make our code very safe? And with that, I will take 2.5 minutes worth of questions. There was somebody over here. Yeah, you had a question.
Yeah, so you told us that bad design leads to bad security. If you don't take that into account, you do. Is choosing C++ as a language a good design decision with respect to security or not? Or what's your opinion at least on that?
Since I do the vast majority of my software in C++, I think C++ is an outstanding language, just in general. As far as security is concerned, C++, I think, is a very secure language. And let me qualify that statement. If you know what you're doing, if you know where the sharp edges are, if you're testing. One of the things that we love about C++ is that C++ gives this incredible power. Well, with that incredible power, it lets you do a lot of things that you probably shouldn't do. We have a standards committee that is not just changing the language overnight. They're taking their time, they're going through these things. We have SG12, which is constantly looking at, can we make the language safer? So I don't really have a problem with C++ as a safe language. The problem comes with how we wind up using the language. Even string copy, if you use it correctly, there's nothing unsafe about it. It's just that we don't. So rather than looking at the language and saying, well, is the language safe? If we were to strip out all the sharp edges on C++, we get Java. And you still wouldn't be done with all the vulnerabilities because there's lots of vulnerabilities even in Java. So I would not look at C++ and say, we don't want to use the language because it's got sharp edges. Every language has them, you just have to be careful.
In the context of, this is recorded, what's your comment to those people who still believe that security through obscurity is a valid mechanism?
Okay, so what's my comment about security through obscurity is a valid mechanism? If security through obscurity was a valid mechanism, it wouldn't be so easy to get past it. Most of what we do with obscurity is I hide a file. Well, that's fine, but if I know you've hidden it, or if I find out you've hidden it, your obscurity is gone. Security obscurity has its place, but it is a weak form of security. A better form of security is validating and verifying the data that you're using, the people that you're talking to. So I don't spend a lot of time doing security through obscurity, simply because I think it's a weak model for security. Is that it? Oh, yeah, back here.
So you showed a lot of tools and techniques for how you can make it more secure. But what would you recommend be the starting one? What, should I go back and start running covariating? Should I try to change our code review mentality? What's the best place to start?
The place I would start would be threat modeling. If you start, you say, so the question is, where would you start? I've mentioned a lot of tools. Which ones would you start with? Coverity is not cheap. Most of these, of the static analyzers are fairly expensive. So I would start with the places where you get the most knowledge. Static analyzers are an automated tool that when you run it, you're going to wind up getting some result, maybe not the results you expect, but you're not going to really learn a lot. So I would start with the places where you as a team will learn. Threat modeling, code reviews, go figure out what the patterns are. There's tons of information out there. You can have people in to train you. What are the patterns? Talk to pen testers, they'll tell you where all the patterns of the mistakes you are. So what you want to do is, especially if you're not talking about going and starting a system up, the ones that give you the most value are things like code reviews, when you understand the kinds of patterns that you're seeing, things that you basically get for cheap. I love dynamic testing tools because they're inexpensive. I can implement them almost immediately. Fuzz testing it's reasonably inexpensive, but it has a really high startup cost. So I would start with the pieces that you see on this list that are the pieces that are either free or things that give you them. And for me, it's going to be threat modeling. It's going to be code reviews. It's getting my head wrapped around a problem that I'm not used to dealing with.
A lot of the static analyzers are implementing the specifications from SEI cert, and you can get the SEI cert guideline, not guidelines, but they're the checkers listed from their site.
Yeah, so in fact, we're out of time, so if people need to leave, we can go ahead and please feel free, because I know everybody has a place to go. So the comment is that a lot of static analyzers are going back to CERT and getting the checkers. That's actually a great place to look. If you want to learn the patterns of the mistakes we make, CERT, MITRE are very good places to go. Go to Patricia's talk tomorrow. I think that's the one where she's doing C and C++ vulnerability. Okay, thank you all very much. I'm going to